manufacturing really at all. The only short staple spinning is in my research laboratories. So that fiber's got to go somewhere, and that's where the Philippines and other countries like the Philippines have America, Germany, all over the world. You have the potential to be taking back their product at the end of life and pulling it apart and putting it back into textiles again. Like what Matthias was showing in his videos. The technology currently exists, we're just not doing it. It's getting the companies to have the defibering lines, to have the equipment. At the moment, the most we're seeing is maybe 5% recycled fibre in textiles. But Matthias showed you a textile that had 60% recycled fibre in it. I've seen textiles with 100% recycled fibre in them. The technology is existing, it's just a matter of applying it. And so we need to get from this current position where only a small amount of the textiles is coming out and actually getting recycled, because this is what's recovered. The recovery rate and the recycling rate is very different. What is happening is it's all ending up like the photograph that Matthias had, either being dumped in a third world country or being taken to a third world country, and some of it may get reused, but unfortunately a lot of it is not. And if we bring plastic into the equation, we have a major problem. You can see the growth in polyester, essentially. Polyester makes up 95% of the world plastics used in textiles. This is a fibre that is in most of our clothing. If I looked and we took everyone in the room, there would be very few people that didn't have polyester on in some form anymore, because we won't be able to buy the oil to make polyester in the first place. So one of those is to replace it with naturally occurring biopolymers. But another option is that we start recycling the textiles and reusing the fibres that are recycled. Suddenly, as Matthias was saying, we have a source of a new raw material, although it has been reused once already. So we really need to be looking at this circle. We need to be looking at how we can make good clothing in the first place. It does not need to be thrown out as quickly. How we can repair it and get it so that it can go around several times. Reuse fibre at end of life, it could go back into the soil and be turned back into a fibre again eventually. I'll talk more about that as well. Now, Australia is a major consumer of textiles. We have, we're the largest textile consumer in the world. And what is really scary is 50% of the garments that are coming into Australia are not being worn. Can anyone understand why? Why do we have 50% garments not being worn? Anyone know? The companies that buy these clothings to import them to Australia to sell them are that worried that they might have one that sells really well and they won't be able to get more of it, so they bring in 50% too much. And so this garment here that sells really well, maybe they sell 80% of them and they only throw away 20%. But this brown one that no one wants to wear, they bring in 100%, they only sell 20%, so they throw away 80%. So they never even get worn and they're going to landfill. So there needs to be a way of changing this. And it is an unsolved problem. There is solutions, but no one is implementing those problems. Now, Matthias was saying that in EU, they're looking at in 2030, you won't be allowed to throw away clothing. In Australia, we have a program called Seamless that is just starting. And it is a stewardship scheme by the Australian government. And at the moment, they've set it at 4 cents per garment. So if you sell a garment in Australia, you have to give 4 cents to the government for every garment you sell. And that will go towards contributing to research and developing the systems to recycle those garments. At the moment, it's a voluntary scheme and not all companies are signed up. And our government has said that if people don't sign up and they get re-elected in the next term, they will make it compulsory and it won't be 4 cents anymore. The money will go up. So they've left it at the moment to try and encourage the manufacturers. But if the manufacturers don't do something or the retailers don't do something, then they will increase it. At the moment, it is only thinking about reuse. It's not thinking about recycling, but we believe that will change in the very near future. But the question I've got is, what do we do with the recovered textiles? And that is a question, if I was a manufacturer, I didn't work at a university, I owned a big manufacturing facility with cotton spinning in it, for instance, I'd be looking at how I can get waste garments and set it up so that we have all of the equipment in place to enable us to start to create products from recycled fibres and from new fibres. And the reason for this is industry is going to want those product demonstrators. They're going to want to know how that garment is going to perform. So we have a range of different equipment, and I'm trying to sort of put it into a flow chart of all the different spaces and how they all interconnect. But this enables us to, for instance, with natural fibres, bring them in to non-woven fibre. The way the building's set up, it's really hard to get a photo of the entire room. And we have a mixture of small and large footprint equipment within our Future Fibres facility. So, an example of some of our equipment. This is our melt and wet spinning equipment. On the left-hand side is one of our laboratory wet spinning lines. We have a small one like this one, and then we have a larger industrial one. Our melt spinning, this is our larger of our 2 melt spinning lines. This enables us to make our own fibres. When we go into short staple spinning, this is our laboratory short staple spinning line. I can take a small amount as 20 grams of fibre and put that into a yarn. So it means that if you want to sample 10 different levels of recycled fibre with a virgin cotton, we can very quickly do these experiments and we can understand how that's going to perform. We can put that into a yarn, into a fabric, and then we can start to evaluate all the properties around that. We have carding, draw frame, roving, combing, and also spinning. And this is an example of something that we've taken through this process. This is a wool cotton blended yarn. You can do 50 kilograms to 100 kilograms through our carding line, and then we can duplicate everything we do in our sample and make larger scale batches. At the moment, we've just finished doing a large spinning run where we did. To complement this, we have small-scale weaving. I don't have larger-scale weaving because I go out to industry for larger-scale weaving. We still have good ones, you can test it. We also have a carbon fibre loom as well. Again, we have small-scale knitting. So we have a Shimaseki first machine, or Shimaseki whole garment machine you can see here. We also have a panel machine. But most of our work is with the 10-inch or 10 centimetre and the 25 centimetre diameter circular knitting machines where we're making a single jersey fabric, mostly for testing purposes. And we have some non-woven capabilities, but nothing like what Matthias had. Again, very small scale, air laid and carded along with legal punching. So some examples of research that we're doing with this. The first one that I really want to talk about is perpetual pigments, and this is one of the most exciting ones that we've done. What we're able to do is we're able to take a coloured natural fibre product and at its end of life we can powder that, and the powder retains the colour of the garment. So if you have a red cotton garment and you turn that into a powder, you end up with a red powder. the entire garment is turned into that powder, so there's no waste, unless there is some embellishments like buttons or zips on it that you have to cut off. So you have no waste at the end of the process. It only uses water and power. It doesn't use any chemicals. And what we end up with is a direct substitute for pigments. And we have used this in paint. We have used this in printing of textiles. And we won a Global Change Award for this particular work back in 2017. So if you want to find out more, you can go onto that website on Perpetual Pigments, and you can see some of the industry partners that we're working with on this. So Rip Curl are in the process of starting to use this in some of their gardens. The next one I want to talk about is mud to marl, and this one really shows the capability of our spinning facility. It also is still looking at that circularity approach. Now in this one here, what we have done is we've tried to reduce the impact of this textile. So anyone who does dyeing knows that when you dye cotton, a lot of the dye ends up going down the drain. You need a lot of peroxide and chemicals like sodium hydroxide and peroxide. You need a lot of salt. And typically only 80% of the dye goes onto the fibre, or in some cases even worse than that. When we dye wool, we don't need anywhere near as much salt. There is no peroxide or lots of chemicals. And almost 100% of the dye goes onto the fibre. So in this case here, we dyed the wool first, and then we blended it with the cotton. Now marls typically are made up of polyester and cotton. You dye the cotton and you leave the polyester undyed. They contain plastic. This one does not contain plastic. We use we only dye a third of the product, so we're using less than a third of the chemicals of water to colour this product. And at end of life, it will break down. It will biodegrade if we want to. And wool normally shrinks by mixing it with cotton. It doesn't shrink. And Michelle Wools, that we've worked with on this process, have actually expanded this product out, which they now call Equal, and they're manufacturing this worldwide. Another example of a simple product is this one here. When we grow seaweed, and there's a lot of seaweed grown worldwide for food and for other applications, it's grown on a yarn. And so in this case here, we have an honours student. This is, once again, a very simple concept, but it is something with our marine science group that we're able to look at this. Another one, which is 3 of my PhD students, is this one here on composting textiles. So I mentioned before that with that composting process, or reduce the rate of that composting process, they also contaminate the soil. So the last thing we want to do is be using those dyes for composting. So the work we're doing here is very much around developing a method to compost textiles that will become an Australian standard for composting of textiles. And it's very much about understanding which dyes should not be used if you're going to certify something for compostability, and which chemicals should not be used. The last bit I want to talk about is our Future Fibres Hub. So our Future Fibres Hub, and I'll give a couple of examples in the process, is a government-funded research project that involves multiple industry partners. With our Future Fibres Hub, it's very much about looking at functionality and sustainability. And I won't go through every single process, but I'll show you the first one, which is on ulu. So, saying before, we have polyester is something that will be a problem in the future. In this case here, ulu is a company based in microbe that is salt tolerant, and that produces a PHA, or PHPB, whichever way you want to call it, which is then turned into a pellet and is extrudable on standard melt extrusion equipment. Now, the reason that this is so exciting is a lot of water going out to sea where seaweed grows is contaminated with nitrogen. And the seaweed is able to pull that nitrogen out of the water, improving the quality of the water around that river. It's coming from a place where we would not normally be growing food. So it's a bio-derived fibre that is not displacing food production. And they've shown with a lot of work that they're doing that they've got a carbon positive process. And so what we're doing with them with this is to extrude it. And I've put these two images in. This shows some of our initial work we were doing with Ulu when we were using a very small extrusion line. And you can see the cone of fibre that's occurring. And then we're able to scale that to our larger extrusion line where we're now extruding kilograms of their product. And we're starting to put this into textiles and appraise how it is going in textiles. Now, our larger extrusion line, we have a 19, a 38 and a 57 filament die that goes on this machine. And we're also able to do tri-local fibres. So it means that we can develop our own fibres, and if we want to, we could cut them into staples and then go up and spin them as well. Another example of this with another company, interestingly, also out of Western Australia, is Nanolose. Nanolose are creating a microbial cellulose. And microbial cellulose is a very pure version of cellulose. If you've ever had kombucha, this is a microbial cellulose. And what they're doing is they're fermenting up their microbial cellulose. They're then extracting that and wet spinning that into a fibre. And this is very interesting because they get a very pure white fibre out of it. And it's also interesting because they're using food waste to do this. And these guys have commercial production of their fibre now. And this is an example of some of the wet spinning of that. I won't stay on this very long. And then we worked with them to take their initial fibre runs when they were doing their initial trials, and we were able to take that through into a garment within our facility. The last one that I want to show you as an example, which is also a hub partner, is Zefco. Zefco started as a company that made clothing for sailing. And they still have their sailing clothing arm called Psych, but Zefco is very much about new technology for reducing the impact on the environment. And if we look at textiles, 20% of the world global water pollution is because of textile coloration and finishing. The 3% of carbon emissions in the world is because of dyeing and finishing of textiles. It's a very, very large contributor. Now, what Zefco has developed with Deakin University is a water-free dyeing system that works with plasma. And you can see this is their prototype machine that they're building at the moment. This is a render of it, but they are actually building this machine. They're scaling the technology to an industrial level at the university. And with that, I'd like to say thank you for having me here today, and hopefully you've learned a little bit.